Welcome back. We're going to continue our discussion on the various gas laws, and we're going to wrap up ideal gas law with this particular video. Now, the purpose here is, given one equation, it can be used in multitude of forms. So I don't want to repeat myself with the same concept. So every time you see me do a problem throughout this course, I will be looking at the same problem from different vantage perspective. Okay, so how many grams of hydrogen gas are there in 500 ml container at 500 torr and 550 degrees Celsius? Right away, we need to know which equation to use. Well, we know volume, we know temperature, we know pressure. So, and we need to know grams, so which means we need to get moles. So right away, we need to use the ideal gas law equation, which is PV equals nRT. Okay, so if you find moles, then using molar mass of hydrogen, we can get mass. Remember, whenever we want to find G, means you have to backtrack and think you have to get moles first, which we can get from this expression. And then we can come back again and get grams, right? That's the whole point. Now, if you keep in mind, mil, 500 mils, nothing is given in perfect units, right? As you saw, as we work one problem at a time, we see that things are not going to be the way you saw in the previous problem. So 500 mil must be first converted to liter, and we know there's 1,000 mils in 1 liter, so it'll be 0.5 liter. Okay, volume is in the correct unit. Pressure, 500 torr. Well, we know there's 760 torr to get to 1 atm. You must convert, whenever you use ideal gas laws, all units must be in the correct representation. Otherwise, your problem will be really messed up. So 500 torr would be 760 torr over 1, which will be 500 over 760 is 0.657 atm. So the pressure is in the correct unit, volume is in the correct unit. Finally, temperature, 50 degrees Celsius means we have to add that to 273 plus 50, which will be 273 plus 50 is 323 Kelvin. All right, very good. Now, whenever we're dealing with volume, we must default use this gas constant, not the other one. So that means now if we plug everything in, pressure is 0.657, volume is 0.5, N is we don't know, R is 0.0821, times T is 323. If you plug all this in and get N, again, we're extending our knowledge from the previous course. So the N value is 0.0123 moles, right? How many grams do I have? Well, we basically take this answer. Remember I said to get grams, we must first get moles and then work our way back to grams. So all we need to do is find the molar mass of hydrogen, which is roughly 2 grams, right? Over 1 mole. Again, I'm rounding, so I'm getting 0.0247 grams. Now, right away, the area that might give some trouble is how do I go to grams? Well, first solve the problem. Find out which one thing you don't know. Solve it, and right away, you will get the answer, okay? Don't try to think too hard before you actually work out the problem. Work out just like I did, stepwise manner, so you would never ever get stuck. All right, that's actually my suggestion, not necessarily an advice. So this is the second problem I want to work out, where I have given grams of a gas, which we don't know what the identity is, And we know the volume, we know the pressure, and we know the temperature, and I'm asking you for molar mass. I think I have said this a million times. First, we need to know what is that we want to find, molar mass. What's the unit for molar mass? So grams over mole. So we already know grams. If we can find moles, then put them two together and we got it. All right. So right away, we again know pressure, volume, temperature. So right away, we know we need to use ideal gas law. Okay. Pressure, volume is already in the correct unit, liter. Temperature is 30 degrees. So that's 273 plus 30 is 273 plus 30 is 303 Kelvin. And then pressure obviously is in kilopascal, which must be converted to ATM. Now I've given that conversion factor. So 79 point, whatever value you are given is always at the top of the table provided by 1. And then you put the conversion factor here. So 1 kPa equals 0.00987. So that will be 79.97 times 0.00987 is 0.789 ATM. Now we have the correct representation. Pressure is 0.789. Volume is 4.167. N is what we need to find, and then R is 0.0821, and then T is 303. If you solve for N, we know grams, we can just divide grams over moles, and we're done with the problem. It's just you need to know to write the units, and that's a huge step up, and it will not let you down if you do it that way. So we know N is, when I calculate, is 0.0076 moles. Okay, to find molar mass, we have to take 20.83 grams over 0.0076 moles, which will be 2740 grams over mole. That's the molar mass. Right? So we've taken the same equation once we solve for volume, once we solve for mass, once we solve for molar mass. So I'm going to leave you with these two problems to practice, and this will be on your my thoughts. So again, I've repeated myself with one more molecular mass problem and a different problem. Make sure you convert units to the appropriate form. So only when you use ideal gas law, all units must be in its appropriate representation before it can be plugged in and the answer is right. All right. So we're done with ideal gas law. We're going to move on to a separate law next time. I'll see you. Stay tuned.